this worked example involves a neutralization reaction. It's a titration of sodium carbonate with hydrochloric acid. It can be quite difficult with these questions to know really what they're asking for and how to manipulate the information. So I'm going to break it down into about 3 or 4 different steps. In this first step, I'm looking at the first line and picking out from this first line that we've got just over 2.6 grams of sodium carbonate, and from the end that the relative molecular mass of the sodium carbonate is given as well. So we measured out a certain mass of sodium carbonate, here it is, and so from that we can work out the amount, the number of moles of sodium carbonate, by taking that mass divided by the relative molecular mass. And that's the first part of the question. This is the number of moles of sodium carbonate. If we read the whole of the first line, it says a standard solution was prepared by dissolving just over 2.6 grams of sodium carbonate in distilled water and making up to 250 cm cubed. So this mass of sodium carbonate, which we weighed out, we put in a volumetric flask, made up to the mark, and this was exactly 250 cm cubed. Previously we worked out the amount of sodium carbonate, so all of that amount will end up in the volumetric flask. The next line of the question begins, a 25 cm cubed portion of this solution. 25 cm cubed of the 250 cm cubed volumetric flask is 1/10. So we're going to take out 1/10 of the sodium carbonate. So this value here is times 10 to the minus 3, as opposed to that one, which is 10 to the minus 2. This is 1/10 of the amount of sodium carbonate. Sodium carbonate solution was titrated. Here's a titration apparatus against hydrochloric acid, and there's the hydrochloric acid we're going to react against. The final line gives us the last piece of information and really poses the question. 18.7 cm cubed of the acid were required for neutralization. So in the burette it was 18.7 cm cubed, and the question, what is the concentration of the acid? This acid is unknown concentration. Okay, so let's review what we've got. What we've got is a certain amount of sodium carbonate, and then we've got a volume of hydrochloric acid, but we don't know the concentration of the hydrochloric acid. So the way that we need to think here is that we've got an amount of sodium carbonate, and we need to work out the amount of hydrochloric acid which it will have reacted with. The way to work that out is to consider first of all what the equation of the reaction is. E for equation, sodium carbonate reacts with 2 hydrochloric acids. It's in a 1:2 ratio, and that's because the carbonate ion is CO3 2-, so it will require 2 H pluses to react with. E for equation, R for ratio, and M for moles or amount. Now we know the amount of the sodium carbonate because we worked that out previously, 2.459 times 10 to the minus 3. And using this ratio, the 1:2 ratio, we can say that the amount of hydrochloric acid is going to be 2 times that. And this value is 2 times this value here, and that's the amount of hydrochloric acid. So we're almost able to work out the concentration because we have the amount of hydrochloric acid in a certain volume. To work out the concentration of hydrochloric acid, we're going to take the number of moles, divide by the volume. There's the number of moles. This is the volume. I've divided by 1,000 to get it into dm cubed, and 0.263 moles per dm cubed. That is the concentration of the hydrochloric acid.